the O-level question to answer. Okay. Right. Question number 5. Animals adjust their bodies to respond to changes occurring in the external and internal environments by coordination, right? And homeostasis. Reducing of the glucose level in the blood when it rises by insulin secreted by the cells in the pancreas, and pulling away the hand when it touches something hot are example for this, right? Because controlling the blood glucose level, taking the hand away when we touch something hot, they are examples for the homeostasis there, right? Part 1 A, state the action. It's an examples for homeostasis mentioned in the page above. 5.1, right? I'll get the extra page. Right. Right. 5.1. Okay. Question number, I get the page. When you answering, we have tried the correct way of question. And if there's a page, question 5, right? And the part 1, I think, part 1A. 1A. A, right? Part 1A, right? Then state the action which is an examples for the homeostasis. Right? Homeostasis means because controlling the things in the constant level in the body. Here this is a glucose level. It is arranging in the constant level, right? Reduction of the glucose level in the blood. That is the one examples for the homeostasis we have given, right? We will write the answer. A reduction of glucose level in blood. Answer. Reduction of glucose level in blood. For the next part, children, keep a one roll space, part B, right? Because actually in a one question, you have a new question, you have to start with a new page, right? Because for the O-level exam, it is a rule there, right? It is easy to mark, right? In the new question, we have to start in the new page. And the question number 6 or 7 not starting here in the same page. We have to get a new page there, right? Okay. Right. Do not start the next question on the same. In that case, here keep a one rule space. Do not write at the same place all the answers. Part D. There are two types of coordinations, namely electric and chemical. There are two, right? Electric and chemical. Write two differences between the electric and chemical coordination, right? Electric coordination, two differences. Then we can divide the page into two, right? Electric coordination and the chemical coordination, right? Where is that? Coordination, right? And we will write. Then we have to divide the book into two. One side, electric coordination. electric coordination. The other one, chemical coordination. Chemical coordination. Chemical coordination. Later we will. Electric coordination, one children controlled by the hormone. Right? Controlled by, controlled by nerves. Right? By nerves. Chemical coordination controlled by hormones. Keep control space, right? Do not write all we have many papers at the exam. If they ask, you are given in any number of papers when you tap the desk. Right. Number 2, electric coordination faster. And this, within a millisecond, it happens less than 1 second. Faster process. Faster. This is a slow process. And when these things are there, children, we have to get the rule and make it as a table. Right. Okay, electric coordination, chemical coordination, right? Right. We'll go to the other page. Okay. Part C, write down in the form of diagram. Write down in the form of diagram using words and arrow the path taken by impulses in response to the stimulus generated by the hand touching something hot. When just touching the something hot, children, we take the hand away, right? First hot object, right? That is called the stimulant, right? So from this part C, no? Part B, part C, right? Keep a one-word space. Part C. Then a hot object. That's called the because that's the stimulant. What's we get hot stimulant. And it touches the skin. The skin is called the receptor. Right? Then that one gets the sensory neuron. Sensory sensory neuron there. Sensory neuron, then we get it to the interneuron. From the neuron chain, there's a moving neuron is coming out. That's called the motor neuron. Motor neuron. Then muscle takes the hand up. Muscle. Right? That is called the effector, receptor skin. We can get like that. You can write the answer with me, then we'll go to the other question. We can take the time. Part 2 now. We have come to the question part 2. I try to make it a little larger. Too much, no? Right. Part 2, Sumit met a doctor because he was very short for his age. Right? He was very short for his age. The short model. Right? According to the medical opinion, the reason for not growing tall was due to a damaged case to some part of the brain. One part of the brain has got damage in the nerve system by an accident. When he was small, one part of his body brain was got damaged when he was young. Part A, according to this option, the part of the brain to which this damage case. Right, because for the growth hormone is secreted by the pituitary gland. I show you the right now. You can see the pituitary gland here. The growth hormone, somatotropin. This here. This is the part. This part called the pituitary gland. Right. That's the pituitary gland has got damage. Growth hormone. Another name for the growth hormone, somatotropin. Or STH. STH means the somatotropin hormone or growth hormone GH. Pituitary gland, right? PITUITAR. The gland, as we explained, children, that is the pituitary gland. Okay. Right, keep the spelling correctly, PITUITAR, pituitary gland, right? And the second question. Part 2B, explain why this damage was caused by is not growing tall. The growth hormone is secreted by because growth hormone is secreted by the pituitary gland. You can write, because keep our rule space. Right. I have come to here, right? Because you can write with me. Because growth hormone is secreted by pituitary gland. By pituitary gland. Right. Then we will discuss the other next question, right? Part 3. Part 3, right? They say you have come to the plant hormones, like things are there. Part 3. In plants too, there are growth substances affect growth and physiological activities. Name one place where these substances are produced, because some substances, the root tip and the shoot tip at the end of the root and at the end of the shoot also they are producing. Part 3a, shoot tip or root apex or shoot apex at the top of the root, at the tip, grade 9 part, this one, okay? You can understand? Because some, alright, grade 9 parts are coming, right? You can tell. Part 3. Shoot apex. That means if there's a plant, you get this place is the shoot apex. Place known as the shoot apex. Okay. And this part is a grade 9 part, okay, from grade 9 book. It is the plant growth substances like part there. Right? Because some lessons, some questions are coming from the grade 9 also. Right? Next question, part 3b. Hormones produced hormones produced artificially are used for the various needs in agriculture. State 2 such instance where artificial hormones are used. Right, artificial hormones we can use to grow the root for the rooting of the cut branches. If you cut a branch, then to get the root tones like that, you apply some hormones, right? Part B, to get roots for cut branches. And hormones too, right, too. The agriculture. The other one, children, we can tell some other things. This also grade 9 children, right? To get flowers and fruits in off season. To get flowers and fruits in off season. This should be the roots. S letter should be there, right? Roots 4. All right, and to get the flowers and the fruits in the off season, because when not the time. The other days also throughout the year we can get the flowers and fruits. The other one you can understand, they are using the carbide and many other things to ripen the fruits, right? For the mangoes and papo, for many fruits they are using the artificial hormones. They are the carbide like that to ripen fruits. Right? Palaturu either one. To ripen fruits. Please write with me, okay? and to as the weedicide, to kill the weeds, valnashaka lesa, as weedicides. As weedicides we can get. And the next one, name one hormone that produced artificially. There are many children, right? Artificial hormone. A, B, C. Not only one, I write a few for you. C, IAA. That means indole acetic acid. For the exam IAA writing is enough, right? Acetic acid. And IAA. And another one we can tell indole acetic acid 2,4-D. That's a weedicide. 2,4-D. That means 2,4-dichlorophenoxyacetic acid like that. Okay. That's a weedicide. 2,4-D. Right. That's enough, right? Another one, ethylene. Like the one gas there. Those things we can write IAA. 2,4-dichlorophenoxyacid. Right? It is a grade 9 book. It is there, children. Part C. Then we come to the part 4. Sunil is a young man, right? But because of his beard has not grown, right? But he is young, well grown, but he does not get the beard there. He looks younger than his age, because as a podikolua like that, he is seen there, right? One day when he was going on a journey, a dog jumped at him barking. A dog came to him as if driven by some novel form of energy, get more energy and ran very fast. He has never run before, right? Very fast he ran, right? Explain the situation presented by the statement printed in the dark letters regarding the hormone activities. Because his beard has not grown, right? That means that to grow the beard, children, male hormone should become, right? Beard has not grown. That the reason of the testosterone hormone is not released in the enough testosterone hormone is not released there from his testes, right? Those are control the male characters of the body. Beard has not grown, right? We write part 4. Part 4. Beard has not grown. We write this one. Part 4. Beard has not grown. The beard has not grown means, children, is enough testosterone hormone is not released by his testes. Enough testosterone. Hormone is not released by his testes. And get the other one ran very fast. Because to run fast like that children, he get the adrenaline hormone from the adrenal gland. This adrenal gland release more adrenaline hormones. Run very fast. Adrenal glands release adrenaline hormone. When the sudden situation, when get excited, the adrenal gland release the adrenaline hormone there. Number 5. Sexual reproduction is important for the continuous existence of some plants. For this process, there is a grade 10 lesson which take place through the fertilization of gamete of the plants, have adapted to the self-pollination and cross-pollination. Explain the action denoted by the fertilization, and the cross pollination. Right. I just explain for you knowledge. I just draw there. Part 5. No? Part 5. Cross-pollination mission, I just tell there are 2 plants there, and it is having right, I just draw another plant. Do not draw plant these trees, children, okay, for to explain the lesson only I have drawn. This one flower, right? It is having the pollen. Having pollen. How can I make this? Right. This plant also having a similar flower, right? And this one also having a same flower, right? Cross pollination means, children, right? a pollen of a one flower. Okay. No problem, right? Pollen of a one flower is going to the stigma of another flower. It's a cross-pollination. Right? And the same tree also, children. Right? From this one, that's a cross-pollination. Another flower. Same tree or another tree. That's a cross-pollination. Right? We can tell, right? We can get 10 going here. It is moved, right? Okay. It is not happening correctly. From that to here also, children, cross-pollination. This is also cross-pollination. But flower from the pollen from the same flower to the same flower called the self-pollination. It's a self-pollination. So called the cross-pollination and the self-pollination. Then what do you mean by the fertilization? I just draw a flower here. The stigma, style and the ovary. Here we are having the female parts called the ovule, right? The flower. And there are many, not only one, right? They finally they will become seeds. It's not. Right? Inside that also nucleus there. Right? This is one flower. I just draw a pollen grain there. Fertilization. Much better we are writing this in the red color. All became much upset children. It's a pollen, right? Because these are the petals of the flower, because we have drawn those things early. These are the petals of the flowers. And these parts also there. Then this pollen, children, grain, is coming from one flower to another flower. Right? It sex. After that, what's happening, children? It makes a tube called the pollen tube. Right? I get the eraser and erase here. From this side, children, it makes a tube. Develop a tube. and growing to here. It makes a rod, it develops a tube. Right? Along the tube, children, you can find that nucleus. This one is going. And this is the male gamete in the red color and the female gamete in the black color. It's a female gamete, there's a male gamete. Male gamete is coming and meeting the female gametes. Okay. Then if you see it as an animation, we can show. Somewhere here. It is coming. Male gamete there. Petals of the flower there, right? Again, right? It makes the tube, that's called the pollen tube. We can't get it more than that, children. Along the pollen tube, children, male gamete is going here. Right, I have to explain that completely as a lesson. I explained it as the pollination, fertilization, right? Pollination means there, that one, right? We will explain that. I'll say that's explained it for you. We'll read the question again. Make it larger. Too large. Sexual reproduction is important for the continuous existence of some plants. For this process, which takes place to the fertilization of gametes, the plants have adapted for the self-pollination and the cross-pollination. Explain the action denoted by the fertilization and the cross pollination, right? Right. Then we will mark what the fertilization. Fertilization, we can tell meeting the male gametes and the female gametes. For the plants and the animals, both it is same, right? Meeting male gamete and female gamete. Right. And the fertilization. And the other one, children, cross-pollination, right? Is cross-pollination. Because actually the falling pollen of a flower to another flower of the same species. If the falling a pollen of a mango to a coconut, not happening. Falling a pollen of a flower to the stigma of the same species flower, right? And now falling a flower, falling a pollen of a flower to the stigma of a flower of same species. Stigma of the flower of same species. Finish writing, children? This is the first page of the tutorial book. Acid, bases and salt, right? That's we can tell. Acid, base and neutral. Salt is a neutral, right? Some chemical substances we get for our day-to-day activities can be identified as acids, bases and salts. I have given some examples for acid. It's a very short and the simple lesson, right? We can tell hydrochloric acid. The smaller classes also you know chemical formula of HCl. Nitric acid, HNO3, right? There, all the acids here you can understand hydrogen is there. And the sulfuric acid, right? That H2SO4, the dilute sulfuric acid is known as the battery acid. To make the simple cell, also we are using this dilute sulfuric acid, right? And the H2CO3 carbonic acid as a soda water, right? And the Coca-Cola and many other things, soda, it's when the bubbling is there, that's a carbonic acid, right? Carbon dioxide gas is dissolved in water, H2CO3, that is carbonic acid. Another one, children, phosphoric acid, not H2, H3PO4, right? Please correct it as H3PO4. H3PO4, right? Let's go to phosphoric acid. In the motor vehicle chassis, we are applying that. We can write it as H3PO4. Right? You can write this as H3PO4. And the lime juice, it is having the lime juice is known as the citric acid. I write somewhere here, but chemical formula is complex, but I am not writing here. Lime juice. That is called citric acid. Lime juice is known as the citric acid. Finish writing this part, children. And you have to write with me that, okay? And this one, children, here the bottles they are adding at the laboratory like that. Special bottles are there. We can get hydrochloric acid in these bottles. Sulfuric acid, right? That's a 98%. The sulfuric acid. And this bottle nitric acid, right? This person is drinking an acid, carbonic acid as soda water, right? All there, right? Below you can write carbonic acid as soda water. Carbonic acid as soda water. And we'll go to the other page, children. if you go to the next page, children, right, I remove the block here. And the properties of acid, children, they are giving the hydrogen plus ions in the solution. These things very simply understand, children. The properties as the properties of acid. Right? We can get, right? Properties of acids. Understand, acids release H plus ions in an aqueous solution. They release the ions called H plus, HCl, H plus and the Cl minus. See? Grade 10, it removes electron and this one gets one electron. The grade 10, you have understood that. H plus and the chloride. CH3 double OH, H plus and the CH3 COO minus. This is Cl, H plus and Cl minus. CH3 double OH is the CH3 minus and this one goes as the H plus. H2SO4, one S is going as H plus and HSO4 minus. HNO3, nitric acid, it divided as that, H goes as the H plus and NO3 group goes as NO3 minus. This O should be capital. Look, there's a printing mistake. H2CO3, carbonic acid, children. It goes H plus and H2CO3. Right? Another H2CO3, H is also should HCO3. H2, one H plus is going, this 2 is not there. It should be the HCO3. Please remove this 2 here. HCO3. Right? Then that's the thing, children. It is giving the release the H plus ions. These H plus ions, children, burns us, our skin like the children. The acidic properties given by these H plus ions. And next part, children, right? We go the other thing. Acid gets corrosive properties. That means it is damaging our skin. It damages wood. It damages metal, like this. Called corrosive properties. Acid gets corrosive properties so that it corrodes metals, wood, clothes. If that acid fall on the cloth, that's over, children, and burns the skin. Because when I doing the experiments here, children, because actually sometimes one day one trouser, children, even the little fall on the trouser or the shirt, it is over, children. From that, after a few days, children, it is corroding even with the dilute acid, children. That's called the corrosive properties. Please highlight corrosive properties. Okay. I get this one. Corrosive properties. Please highlight it. Sour taste, children. The acids, sour taste. The fruits, they are having more acid, children. You can get a sour taste, children. Right? As an example, what can you tell, children? A mango, raw mango, sour taste. Lime, sour taste. Right? That's the acidic taste. Pineapple, right, having more acidic. And the tomatoes, more acidic fruits. Prickle, that in Sinhala called acharu. That's a more acidic. We added the vinegar. They are having the certain sourness there, right? That's sour taste because of the acids there, right? They are called the acids there, right? And dilute acid release hydrogen gas, having reacted with the metals over the hydrogen in the activity series. Hydrogen of activity series. Hydrogen or hydrogen of the activity series. This one you have to keep in your mind, the activity series. The grade 10 also with the extraction of metals, I gave the activity series. That's important there, right? What's there, children? The magnesium joins with the HCl. Grade 10 also I gave same equation. Magnesium joins with the HCl. In that case, this hydrogen come out. And magnesium joins with the chlorine, single displacement reaction. Right? It becomes the magnesium chloride. That means when the magnesium joins with the chlorine, MgCl, valency of the magnesium is 2. Then we write the 2 here. Valency of the chlorine 1, in 1 we are not writing. Hydrogen, normally it is living with the 2 hydrogens together. In that case, we write as the H2. Okay. In that case, to balance that, children, we can add the 2 here. In that case, it is balanced. How do we balance, children? We start from here. 2 hydrogen are there. This side 1 hydrogen. In that case, in front of all children, we write the 2. Then what about that? Then the chlorine also become 2. But here, chlorine 2. Oh, no problem. Magnesium 1, magnesium 1. This balance. Yes, zinc joining with nitric acid. What about that? Zinc removes this hydrogen. Normally hydrogen is living as the 2. And the zinc joined with the nitrogen, what's happened, children? I erase it. Yes, and do it for you again. Right? Okay, here the zinc metal, joined with the nitric. In that case, this hydrogen goes out, replaced by the zinc. Zinc joins with the nitrogen group. Zinc attack this combination and replace hydrogen, displace hydrogen, and zinc join with the nitrate group. I mark that. Zinc goes with the nitrate group, and asalan hydrogen remains. But hydrogen naturally in the atmosphere we can find the 2 by 2. In that case we write as H2, right? We make it small that it affects that diagram. Zinc joined with the nitrate group and hydrogen is replaced. In the atmosphere hydrogen we can find H2. But the valency of the zinc is 2. 2 should be given to the total nitrate group. Then we make a bracket here. Add the valency of the zinc 2 to the nitrogen group. But valency of the nitrate group is 1. We do not add 1 to, normally we are not writing. To balance 2 hydrogen, 2 is there. Then what should be there? There we write the 2 this side. Then nitrate group also becoming the 2 here. In that case it is balanced. Already 2 nitrate groups are here. Aluminium plus sulfuric acid. Let's discuss it. Then aluminium attack here. Aluminium join with SO4. Then these 2 hydrogen remains here. Then aluminium goes with SO4 group. there are 2 hydrogen already, H2 there. You can find this one, the valency difference. Valency of the aluminium is 3. That 3 should be given to this total SO4 group. We make a bracket here. Valency of the aluminium we write to here. The sulfate group also having a valency. Valency of the sulfate group, children, 2. That 2 should be given to aluminium. After the aluminium, children, we are writing 2. This 2, Al2, SO4 tries. Right? Right. Now, how to balance children? Both we have to balance here. First one we will balance 2 hydrogen. It is auto balance children, right? And this one 2 hydrogen there. Hydrogen balance, right? But sulfate group 3 here, right? But here sulfate group 1. In that case, total this factor we have to multiply by this 3. Okay? We write the 3 here. Then what happened? Hydrogen became 3 into 2, 6. Sulfate 3 is correct. 3 into 2, 6. But here only 2. To make the 2 into 6, what should we do? We have to multiply this also by 3. Then we set a 3 here. The aluminium 2 this side 1. Then we are writing the 2 in front of aluminium. The simple way, right? These reactions, children, they are giving a hydrogen gas, children. Right? It is releasing hydrogen gas. How can we identify the hydrogen gas, children? If you bring a fire closer to hydrogen gas, children, it gives a pop sound. Okay. We can identify the hydrogen gas like that. Did you write this part, children? Finish writing? Finish writing? Or not? Pavani, finish?
Yes.
Okay, then I'll explain this one, the other part. Here. Now, in this setup, children, here, magnesium pieces are there, and the dilute hydrochloric acid. In that case, gas bubbles are coming. There's the hydrogen gas. This test tube, the stand, and the delivery tube, children, is going to the water and coming up. That person applying there's a candle here. Right? Soap bubble filled with the gas because soap water there. In that case, soap. That's a very nice experiment he has added. I have not done this kind of experiment. That's a very good thing, right? It's hydrogen bubbles are coming, then the soap water there. Now, these soap bubbles are coming, children, with the hydrogen gas. These bubbles are having the hydrogen gas. Then, when you bring a candle, children, pop like sounds are coming. Right? That's a very good experiment to do, because to save the time, children, I'm not the grade 11. We are not going to do experiment much here, because we have to get ready for the exam, right? You keep it in your mind. That's a good experiment and exciting one. But I told metals, they are reacting with the acids, some metals, not all metals. Right? You can find the less active metals, children, right? In the activity series. Gold, like metals, not reacting with hydrogen. Au gold with HCl, no reaction. Dilute acids do not react with the less active metals below hydrogen. In the activity series, you write hydrogen. In the activity series, here also you can write with me. Hydrogen. activity series. Finish writing, children, because I have to show you the activity series. Now I'm going to show you the activity series of metals, right? Now it's the activity series of metals. If I make it larger, metals, see, we have a mark, right? And because this is the hydrogen here, this is very important. We have to mark hydrogen. Hydrogen, right? Then the metals above the hydrogen, children, they react with the activity series and release hydrogen from the acids. Magnesium reacts with the HCl, it releases hydrogen. Zinc, they release the hydrogen. Aluminium, that means these metals are active than hydrogen. They remove the hydrogen. But this gold is less active than hydrogen. In that case, gold is unable to remove hydrogen there. You can find these metals, children, can react with the acids and remove hydrogen. These metals are unable. Here, gold, they are less active than hydrogen. In that case, it does not react with the dilute acids to remove hydrogen. These metals are not dissolving in the dilute acids. But the active metals, they are the hydrogen, children, they dissolve in the acids there. But these things I have given as the activity series. Right? Potassium, barium, calcium, sodium, magnesium, aluminium, manganese, zinc, cobalt, iron, cadmium, nickel, tin, lead, hydrogen. In this our world, Earth, it is a gas, children. But in the very cold planets, children, we can find, children, it is as the solid like that. Okay, if it is solid, it's a work as a metal. Copper, arsenic, like in the pesticide, it is there. Antimony, bismuth, mercury, silver, platinum, gold, they are not considered as the good expensive metals. No, copper, silver, gold, platinum, right? Then for us, children, we need these things only for our lessons. Potassium, calcium, sodium, magnesium, aluminium, zinc, iron, tin, lead, only that. Others, we are not talking for the O level. And below one, copper, mercury, silver, gold, normally we are talking. But very difficult to keep it in here. Potassium symbol is K. Barium, we write the BA, right? But we are giving our teacher, when we studied when we had the grade 9 class, children, right? And 1983, I remember that. Okay, our teacher gave a poem to know that. Our O-level exam was those days at the grade 10 class, grade 10 O-level, not the 11. Right? Grade 9 class, we have studied that. Potassium K. Right? Potassium we give as a potta. Right? The barium, beruna. Right? Calcium, Kahetu. Sodium, Somata. Magnesium, Maggie. Aluminium, Alisa. Manganese, Manchi. Zinc in Sinhala we are telling as the Tuttaragam. That's why they get as the Tundena. Right? Not Tundena, Tundena. Manchi, Tundena. Manchi, Tundena. Cobalt, CO. Hot iron, Fe, we write. Iron in single we as Yakade. Cadmium, CD. Caduna. Nickel, Ni. Nicotete. Tin, Mr. Tiger King, lead PB, reduct tin we write as SN, hydrogen H, Hadda, copper Cu we write, Columbator, copper Columbator, arsenic, Asa Ati, Columbator, arsenic, Asa Ati, antimony, anti-gay, we write this as SB, arsenic, AS, bismuth, BI, binariter, mercury, HD, mercury in single called the Rasadiya, Rase, Rasadena, silver, AG, right, in single silver known as a Riddhavala, platinum, PT, Pannalu, gold, AU, gold we write as gold in single Rattaran, Muddat, Ragin and Andana. We can remember it as a Potta Beruna Kahutu Somata, Maggie, Elisa, Manchi Tundina. කොට්ට යකඩෙන් කැඩුණු නිකටට ගසහලා ටිකකින් ලෙඩක් දෙන. අද්ද කොළඹට ආස ඇති හැන්ටිගේ බිනරිට රසයේ රස දෙන රිද්දවාලා පැන්නලු රත්තරන් මුද්දත් රැගෙන නන්ද. Our teacher gave, but we need children only this metals I have a tip there, right? The metals above hydrogen children, they react with the dilute acids. Metals below hydrogen children do not react with dilute acids. Please write it down, children, how many minutes you want. 10 minutes or 5 minutes. Right. Please write down the activity series of metals. I have added you 5 minutes for this. So you have finished writing it. Yeah, right. Now look at here, children, the acids, because they are released the carbon dioxide gas with the, right, the other property releasing carbon dioxide gas by a reaction with the carbonates and the bicarbonates. Right, it releases the carbon dioxide gas. Right, you can see it. I erase and write it again. In that case, it is better to explaining you it again. Now it's all are same as the one place, not so clear this one. Right. Then first one, children, HCl acid is there. Right. You can find HCl acid. It reacts with the calcium carbonate. Calcium carbonate is the limestone. The coral reefs, in our bones, in the shells of the snails, we are having the calcium carbonate. Then HCl, because HCl is the calcium carbonate. What happens, children? It is doing this one, children. Chlorine goes with the calcium. Calcium chloride, it will become, right? Right. Ca, calcium joins with the chlorine. Valency of the calcium 2. And it is giving children water and the carbon dioxide after joining this one, right? It's going make the water and the carbon dioxide gas, right? It produced there, right? H2O and carbon dioxide gas there, right? We can get that, right? Calcium carbonate. Then what about that? There are to balance that, please I think much better, right? Writing here, it's that here 2 chlorine here. This side 1 chlorine, right? We add the 2 to this side. Now it is balanced, children. 2 hydrogen. right? 2 chlorine. And the oxygen 2 plus 1 3. Here oxygen 3, carbon 1, calcium 1, right? Please write it with me, children, right? HCl is dissolved in water, we write it as the AQ, right? This physical properties also, children, we have write AQ. Calcium carbonate is a solid. Calcium chloride also dissolved in water, AQ. Water is a liquid. Carbon dioxide is a gas. And this one, sulfuric acid. Sulfuric acid and the calcium carbonate, there's also limestone. Sulfuric acid is also AQ. AQ. Calcium carbonate, limestone is a solid. Right? Then what about that? You can write it with me. Then calcium goes with the sulfuric acid. Right? Calcium joins with the sulfuric acid. CaSO4, right? Calcium sulfate. And the hydrogen and the carbonate group, children, that's also same. They are joining together, water and carbon dioxide gas. Plus water and carbon dioxide gas. And it is auto balance there. One calcium, one carbon, 2 hydrogen, 4 oxygen, 4, 5, 6, 7, right? 4, 5, 6, 7 oxygen. It is auto balance. Calcium sulfate, AQ. Water is a liquid. Carbon dioxide is a gas, right? HCl plus sodium bicarbonate, that is also same, right? That's a sodium joins with the chlorine. Sodium chloride, that's also water and the carbon dioxide. I write it. Sodium goes with the chlorine, NaCl. Plus, this part also same, water and carbon dioxide, H2O. Plus carbon dioxide. Plus, there's also auto balance, children, right? One sodium, and 2 hydrogen, 1 carbon, 2 plus 3, 2 plus 1, 3 oxygen there, right? It's balance and the physical forms HCl, AQ. Sodium bicarbonate also AQ is a solution. Or sometimes we can find as a solid. Also there you can write. If it is well dissolved in water, in that case we can write as the AQO. Solid also we can use. Sodium chloride dissolved in water, AQ. Water is a liquid. Carbon dioxide is a gas. Right? This reaction, they will come. Sulfuric acid and sodium bicarbonate. That's also same, children. Sodium joins with the SO4 group and hydrogen. These things, water and carbon dioxide. Right? And we write sodium joins with the sulfate group. Right? Valency of the sodium is 1. In that case, 1 we are not writing. there. Valency of the sulfate group is 2. 2 is given to sodium. Na2SO4. Plus these things, hydrogen and HCO3, they are joining water and carbon dioxide. Water and carbon dioxide. How to balance it, children? Right? Sodium 2 in this side, but here 1. In that case, we have to multiply it by the 2. 2 sodium. Hydrogen became how many now? 2 hydrogen plus 2 hydrogen, 4. Here only 2. In that case, make it 4. We have to multiply it by 2. 2 into 2, 4. Right. And sulfate group 1. Here, sulfate group 1. And here 3 oxygen. 2 plus 1, 3 oxygen. It is balanced, children, right? Sulfuric acid, AQ. Sodium bicarbonate also as a solution, I write as a AQ. Or as a, sometimes it's find as a solid also there. Sodium sulfate, AQ. It was dissolved in water is a liquid, L. Carbon dioxide is a gas. Right. The other property is the right. They are conducting the electricity. Right? All the acids is conducting electricity. Now we are talking about the strong acids and the weak acids. If you get the strong acid, children, it is completely they are breaking into the H plus and the chloride ions. It is again, it is not they are not joining it again together. Strong acid completely ionized. Ionized means they are breaking into 2 parts. One get the plus ion, the other one get the minus ion, not again joining. Strong acids completely ionized in an aqueous solution and release H plus ions. They are not joining again, only to this side. But weak acid, that's one example, acetic acid, that's called the vinegar. Right? An example, CH3C double OH, that's called the acetic acid. Right? Acetic acid is a weak acid. What it's ionized partially, right? Weak acid ionized and release partially ionized and release H plus. H plus should be go to there. Right? Okay. Partially ionized and release H plus ions. Partially means they are separating children to the H plus and HCO3 minus. But what happened there, children? Again they are joining and become the H3. The 3 should come down here. Okay. H3CO3. There that 3 should come down, right? The H3CO3. It should come down again. They are separating, again joining. Right? That is the partially. Right? Because we have to highlight, children, strong acids